Good morning. I hope you had a great break. I am still traveling back from where I was in Texas and in Atlanta. So I will be back tomorrow. So I just wanted to go over some things with you. This is what we would have done if I had been in class. So we're just going to go ahead and do it now. You will have an assignment at the end of this video that will be due during class today. So I want you to turn it in today at the end of class. Okay, so these are some of the things that we're going to go over, but we're mostly going to look at maybe domain and range, a little bit about piecewise functions, some inverses of functions, and a little bit of other stuff sprinkled in there. All right, so let's look at this. We've got the function y equals x squared minus 3. So if you went to graph that, you know that the parent function is y equals x squared, and this is a translation where it's translated down 3. So we're going to go and move the vertex down 3. And then you do basically, because there's nothing in front of the x squared, it doesn't change the width of it, so we're just going to go ahead and graph it. I'm going to go ahead and pause to save time. You can put this in your calculator and look at it, or you can go ahead and graph it on paper. Okay, so it's not quite exactly right, but it's pretty good. I wasn't able to use a stylus, so it took a little bit, it's a little bit less exact. So here we go. So what would be the domain of this function? Well, in words, the domain would go from negative infinity, oh no, it would go from negative infinity to positive infinity. So I'm going to go ahead and label this. This is negative infinity, this is positive infinity. The y values are positive infinity, and the y values down here are negative infinity. So it's all reals for the domain. So what we do when we write it, you can write it as negative infinity is less than x, and that's less than positive infinity. Or you could just write it as negative infinity and positive infinity, and we make the curly brackets because it means it could not be equal to that. All right, what about the range? Now we go, where is our lowest y? Or our highest y? Well, our highest y is going to go all the way up to infinity, but our lowest y starts here at negative 3. So let's write that in our new kind of set notation. We would write negative 3 with a hard bracket because it could be equal to it. And then we put a comma, and then it would go up to infinity, and then we put a curvy bracket because it cannot be equal to that. So it's implied, because we're talking about range, that we're saying y. All right, so let's go on and talk about something else. Now, what would be the domain of this? You can graph it, but really you don't have to really graph it in order to look at it. This is really a rational function, and it means that it is moved to the left, to the right 5 spaces. So it's going to be a little bit wider, and I'm not going to draw a real exact graph, but the asymptote is going to be at 5. So I'm going to draw a little line here, a little dotted line. And I do believe that it's probably going to look like that. I'm not using a calculator and I'm not plotting points, but I'm going on memory, so I could be a little wrong. But it's going to look something like that. But really, when we're talking about domain, we're talking about, let's go ahead and write this out, domain. We're talking about where is x not allowed to be. Well, if you notice, it curves off here and avoids that x. It goes up this way and avoids the same x. Or you could talk about what's going to make that be 0. So we've got, well, what is x minus 5 cannot be 0? That means x cannot be 5. So really, when you want to write out your domain and your range, for that, we know x cannot be 5. So I'm going to make a little note of it. And then we can write that it's going to go from, now you can get real complicated, negative infinity. I'm not going to use that bracket anymore because it's a little bit old school and we're trying to move into that. Negative infinity to 5, and it cannot equal 5. So we're going to put a little soft curve there. We're going to do another one at 5, and it goes on to infinity. Those are the two intervals of the domain. It goes from negative infinity to 5, and then it goes from 5 to infinity. All right, so let's talk about the range. Now the range is how high and how low does it go and what does it avoid? Well, it looks like it's avoiding this line right here. And we know that that line is y equals 0. So y cannot equal 0, basically. So let's go and write that out. So it goes from negative infinity, and then it starts to curve off at 0. All right, it cannot equal 0. And then it starts again at 0 and goes up to infinity. So 0 to infinity. There's how you write domain and range. All right, let's go on and talk about, I think I just pretty much talked about interval notation, so we'll talk again, right? So if we wanted to say all reals, we used to say, let's pretend we're talking about domain, all right? We would go and we would say now instead negative infinity, comma, positive infinity. It's a lot easier. If you wanted to say something was x is greater than or equal to 0, how would you write that in interval notation? You would write a hard bracket here and starts at 0 and it's greater than 0, so it's going to go on to infinity. So this is a newer way to do it that doesn't require so much writing. All right, now remember we're evaluating functions at a given value of x. We're getting ready to do some things with that, so that's why I want to review that. So you've got f of 3. Well, when you're doing f of 3 of something, you're going to plug that number in. Go ahead and evaluate that, and then we'll talk about the answer. Okay, so I plugged in a 3 for x, and I made all the other things come down exactly the way that they were before. And then I evaluated it, so 2 times 3 is 6, 6 plus 3, that gives us 9. So f of 3 is equal to 9. Let's try the next one. You're going to plug a negative 2 in for x. Now you've got two different x places here, so go ahead and work that out. See what we get. Okay, so I put a negative 2 in for x. You got to be very careful. Now 5, then if you have negative 2 squared, that's really going to be a 4. And then plus 3 times negative 2, that's going to give us negative 6. And then we're going to subtract 2. So this is all order of operations. So now we're going to go and do the 5 times 4 is 20. Plus negative 6 minus 2 is negative 8. So 20 plus negative 8, or 20 minus 8, is 12. All right, let's go on and look at some other stuff. What if you wanted to do compositions of functions? I'm only going to do one. I'm going to do the harder one to save time, because we should be pretty comfortable with this by now. So we're going to do g of f of x. So this really stands for g of f of x. Okay, so you're putting the whole entire f function into the g function. So let's go do that real quick. I'm going to write the g function as x squared. All right, so instead of x squared, we're going to write 2x plus minus 3. And then we're going to square it. And then we're going to go, I can't get this thing off. Okay, so I put 2x minus 3 in for the, in the x value. Now we're going to subtract 2 times, and again, we're going to put 2x minus 3 in there. Now you just evaluate it. So this takes a little bit of foiling, all right? A lot of you have had a problem when you're squaring a binomial, you're forgetting to FOIL. This really means 2x minus 3 times 2x minus 3. And then it's minus 2 times 2x minus 3. Now this would be easy if we could factor out a common factor, but I'm not going to go there right now. It could get confusing. So go ahead and FOIL this out and then check. Okay, so far I've got this, and then once I go and combine my like terms, I get 4x squared minus 12x plus 9. Then I go and I'm going to just distribute the other guy over here. Now remember, the negative is being distributed. So it's minus 4x plus 6, because negative times a negative is a positive. So we've got minus 4x plus 6 down here. Now we have to go and combine the rest of our like terms. So we've got, let's see, 4x squared is our only squared term. Negative 12x minus 4x is negative 16x. And then 9 plus 6 is positive 15. And that would be the answer for that. If you wanted to know the domain of that, well, the domain, if you graphed it, if you put this in a y equals and graphed it, it's a quadratic. So that's going to be all reals. Okay. And when you write all reals, you can write it like this. It's a lot easier. Okay, let's go on and talk about graphing piecewise functions. I'm going to go ahead and graph, and here's what you do. You're going to make a table, so you're going to do y equals 3, and you're going to make a table for just y equals 3. Well, we should know by now, what does the graph of y equals 3 look like? Well, y equals 3 is a straight line. But now this is only going to be where x is less than or equal to -1. So we're going to pick all of our x's that could be less than or equal to -1. -1, -2, -3, and then we keep going. Go ahead and graph that. Where did it go? Sorry about that. All right, I plotted all those points. So what you're going to do is you're just going to go and now it's going to be less than or equal to. So it's going to keep going. Less than, and it could be equal to. Now the next thing you're going to do, let's look at the next one. You've got y equals 4 minus x. So we're going to go and put in 4 minus x. And we're going to go between -1 and 4. So make your table to go between -1 and 4 and fill that in. Okay, there's my table that I made. Let me go ahead and plot these points. -1 and 5 is right here. Now remember, it's not equal, so we're going to do a bubble. And then we've got 0, 4, 1, 3, 2, 2, 3, 1. And then it could be equal to that one, so we're going to keep that as a dot. And then you just fill in between. All right, the last one you've got is going to be y equals 3x minus 10. And do x and y. And then let's go ahead and fill in our table, and it's going to be just greater than 4. So 4, 5, 6. Remember, it's going to be a circle there, though. All right, go ahead and fill in that. Okay, so now we've got our points. We've got 4, 2. Remember, it's going to be a circle there because it cannot be equal to 4. So we're not going to let it be a dot there. And then we're going to plug in 5, 5. So 5, 5, and 6, 8. And that's where that one stopped. Well, it actually doesn't. Oh, Lord, I went on the wrong one here. It really doesn't matter because we're just still doing the same one. We're on this one. Same thing, though. Just fill it in as a circle. You're going to keep going. La, la, la. There you go. And then because it's greater than 4, it's going to keep going in that direction. All right, that's how you graph a piecewise function. It looks like little pieces of different graphs. All right, I think I have one more thing for you. Let's go on. All right, you're going to graph inequalities. So let's go look at this inequality. Graph y is greater than or equal to 2. So you're going to graph the line y equals 2. And then when we go to shade it, it's going to go greater than. So I'm going to use a highlighter, and I'm just going to shade above, greater than. And then we've got the line, or the curve now, y equals, y is less than or equal to x squared minus 3. We already did that one earlier, so I'm going to do something just like it again. All right, get the idea of it. Okay, and it's less than that. So we're going to shade less than that curve. So let's go, and I'm going to give it a different color. Less than this curve. This is going to be interesting because it's going to go below, goes all below, but then it's going to go and intersect right here, but it's not going to cross over. It's kind of a weird looking graph. Okay, so the only thing that's really going to be shaded, this is going to be interesting, where it turns green. So none of this is shaded. All right, I accidentally erased part of that other graph, but you get the idea. Where it's green, it's going to be shaded. All right, so let's go on, and that's really all there is to do in that kind. So it doesn't get too complicated with that. All right, I think I've got one more thing, but I'm not sure how much time I've got. Finding the inverse of y equals x squared plus 5. Switch your x and your y. So we're going to do x equals y squared plus 5. I'm going to go ahead and work it out. Okay, I switched my x and my y. I'm going to solve for y. So I've got x minus 5 equals y squared. Take the square root of that, and you're going to get y equals plus or minus square root of x minus 5. Is that a function? No, it's not, because it's going to look like a parabola on its side. All right, your assignment is going to be here, and I'm going to send this to you in a different file. Okay, so you've got about 10 problems to practice, and I want you to turn them in today at the end of class. They are due today. All right, have a great day.